Okay, I'm going to start recording. So anytime, it's 2:02, and there are already 13 students here. More will come, but yeah, take it away.
Okay, great. Well, this is good fun. Thank you for having me back again. I enjoy coming and talking to the class. I think some of you were here last year your last term. Was that true? Like we have repeats. Is anyone here?
Yes, there are potentially. Yeah, both of the TAs have taken the course before, and the people who are returning alumni have also taken it before. So they may have had exposure to you before. Yeah.
Okay, cool. So let me try and open. I'm going to try and open the chat bar. Sorry, I'm doing stand up here. There we go. Open the chat bar so I can see that as well while I'm looking at you. So my hope for today, so those of you who don't know me, which probably most of you, I'm Patrick. I'm a professor in the Department of Medicine, really focused on some of the core technologies of artificial intelligence, but as they're applied to bionic body parts. So this intersection between intelligent machinery and the human mind and the human body. And so that sort of biases where I'm coming from. But because of that, I like to sort of zoom out and think about some of the promise and perils of AI as per the topic of the section of the course from a bird's eye view, and have us discuss those topics in a way that satisfies all of you and helps to synthesize some of the knowledge that you've all gained from the last little while. So I believe Osmar gave 3 lectures again this time?
Yep.
Okay.
Yeah.
And more or less similar to his usual tone, or was there something different? I'll ask the class, of course, as well, but Kim, I'm really looking at you right now to.
No, there is always new stuff, but it was pretty similar in general theme. Yeah.
Okay, awesome. And did Rich talk this? Did you have anyone else speak, like Rich or someone else? Okay.
No, but they're still required to know things about Rich's beliefs. So anyway, whether they meet him or not, they're still required to know what he believes. So yeah.
Well, that's the detailed task. Okay, great. So I think I'd like to do the thing I usually do when I come and visit the class, which is to find out a little bit about where everyone is coming from. And so if that's okay, I don't know how this most easily managed via Zoom, but if folks who are comfortable chipping in via voice or even just via the chat bar want to quickly say their name, what program or field of study they're in, and maybe one thing that they're particularly interested in with respect to through AI or AGI, I think that'd be really helpful. So if we can go around, I don't know the right way to coordinate the going around the table in a setting like this, but maybe someone wants to jump in first.
Yeah, well, they can probably be spontaneous. Somebody who's really eager to talk can be first. So
I can go ahead and start. Hi, my name's Nadia, and I'm doing a wonky combined degree in science and education. And I'm just interested in AI in general. Like recently I read an article about AI, helping out astronomers with identifying types of galaxies and stuff like that. But yeah, just interested in everything.
Okay, who wants to go next? So Young, do you want to go next?
Sure. Are we just doing simple introductions on why we're interested in AI?
Mm-hmm. Yes, please.
I'm So Young. I'm in my last semester of my undergrad degree as a philosophy major and women's and gender studies minor. I'm interested in AI and technology in general just because I work with Edmonton's vulnerable populations in the inner city. And the community that I had the privilege to enter is very disconnected from technology, but at the same time, we are moving towards technological advancements. And I think that technology could either be utilized to really help solve systemic, socioeconomic, and political issues, or it could really increase the gap between the privileged and marginalized. So that's why I'm interested.
Thank you very much.
Yeah, he has used.
Does anyone else want to jump in? Kim, I think you're off. You're not on mute as well. Just as a.
Okay.
Anyone else want to jump in next? Cool. Thank you, chat. Chat works too.
Yeah, I'll just post mine in the chat because, we have discussed things like this, who we are in past. So I think that'd be the fastest method for everyone's to jump in. But yeah, there's mine.
Cool. Thank you very much. And we keep going. If people just want to hang out and not chime in, that's fine too. But it'd be good just so I'm trying to calibrate it. Cool. Neuroscience as well. This is awesome. It's partly me calibrating as well, so that the kind of topics we discuss over the next hour or so are something that will hopefully appeal to and give room for conversation for everyone involved. So, but I see there's already quite a bit of diversity in terms of the topics of study. So this is really good. Wow, this is one of the most, I'm just sorry, I was looking at chat. If you see me scrolling with my eyes here, it's one of the most diverse. We have medicine, neuroscience, biology and computing science, neuroscience as well, psychiatry and therapy. Wow, okay, great. This is fantastic. Thank you everyone for chiming in. Music technology, nice. Math, oh wow. This is one of the most broad groups I've seen so far. Pediatrics, fantastic. Okay, great. I'm gonna let if everyone last call for check-ins in that respect, and then we can start getting rolling. And I'm gonna open up again the floor to questions and to suggestions from you as to what your key questions are with respect to AGI or artificial intelligence or any of the machine learning technologies that build up what we might consider to be ambitious or strong artificial general intelligence. But before I do that, I just want to ask a question. I don't think I've asked this question in the class before, but what would, like, imagine you saw a newspaper article coming out and it's like, strong artificial intelligence has been demonstrated. And then it like continues on and describes what that is. What for you would the rest of that article say? What would it be for you? Like if you actually were to be the one saying like, yeah, I just saw this example of us solving the problem of artificial general intelligence. What would that be?
AGI. That's a really good question. I have no clue what AGI would even look like.
Okay.
So
Absolutely.
what about this way of looking at it?
That's so bad.
Is it
Holy
true that narrow AI would never really threaten us, cannot really threaten us, whereas AGI could? So is AGI the only, dangerous kind of AI, or could some very powerful narrow AI be potentially dangerous?
Are we
Is
talking
that a
about,
question for everyone, Kim, or is that? I mean, I have feelings about this. I'd love to hear what everyone else thinks.
like, on the definition of AGI?
No.
Yeah,
How would you define AGI, and are there types of narrow AI which could, wipe out the human race? Or as long as it's narrow, are we safe?
Well, I feel like with narrow AI, like you can still have the danger of, what it's being trained on. I think I mentioned the example of social media before, but like the issue with the, like bipartisanism and radicalization is from us, not the AI itself. AI is built within a black box oftentimes and like needs to be trained on specific parameters. And so with a true AGI, you won't have limitations based on what we've trained it for, and any problem set, maybe something that we weren't even aware of before, it would be able to solve or complete. And so I guess it would be not sure, like we wouldn't be sure what it's capable of, versus narrow, we would probably have a good idea of what it is and isn't capable of.
Okay, very good. And I must admit, I'm asking leading questions and sort of making very broad questions because maybe I'll share my agenda right now. We'll just do this right away, so you know where I'm going with all this. Is that I really hope to, by the end of the next hour, roughly the next hour, to have us discussed what I feel are some of the most important ways of breaking down the problem of intelligence and to thinking about it clearly, and the ways that applications of intelligent systems technology might be deployed. And I usually break this down into, first, the data that's being used by a system, the decisions it makes, and the goals that it's hoping to pursue. And then as themes that move through these different parts of the problem of deploying intelligence, looking at the way that a system starts to represent its world, the way that a system starts to build up knowledge or forecast its world, and the kinds of actions or the kind of choices that it makes within whatever world we've put it within. So like for instance, like Kim's new model robot dog, it's actions, it can move through the world, it can interact with the world, it can in some way move its body with respect to a physical world that it perceives. It represents the world by way of a number of different sensors, and it in some ways will start to form, likely, and I don't know what's going inside the head of the robot dog, but it'll likely start to form some kind of programmatic memory of those representational changes it sees over the course of its experiences. And hopefully, if they've done their job right at the engineering part of the company that created it, it'll actually be starting to build up a understanding of the patterns that occur between its actions and the next things it might perceive in a world. So I'm hoping that we talk about all those things over the next hour, but I'm getting into it by way of asking you all to think very hard about what would it be for you if you were to see artificial general intelligence tomorrow? What would that actually look like? Because I think a lot of people, I'm just going to seed another one, like, would a really good chatbot convince you? Would you say yes, would that be the part of that newspaper article that you saw? Like, AGI was unveiled today and it turns out to be a chatbot. Like, would you say yes, that's artificial general intelligence? Or if not, what would it look like for you? So maybe a couple more responses to that, if that's okay, before we move into some of the more technical parts of the discussion. But please, maybe someone else jump in.
Sure, I'm happy to jump in. Yeah, Patrick, I agree. You know, a chatbot, I don't think that convinced me. I would say, I guess that's a neat trick, but I don't know. There's lots of other things that I would say are more impressive than that, but they're narrow AI. You know, maybe for me, it would have to be something like a general AI that's capable of basically being a human. Like, it can function in a human's job better than a human. It can deal with all the difficulties and the dynamic environment, and it can think by itself and responds and problem solve.
And that's really I think you're hitting on, especially there, a notion of generality. And so maybe this is like the very narrow or focused AI versus what makes it a broad AI. I've never really thought about whether or not a system is particularly narrow versus broad, as opposed to what are the areas where it is designed to operate. What are the specific tasks? Like, looking at Kim's background right now, there's a bunch of things there, and some of them might be deeper than we expect, despite their narrowness, if we believe that they're narrow. So what you're proposing, though, I think in that last statement, is that there is a notion of being able to deal with complex and changing environments, and by grounding this in, say, doing tasks that humans might do or doing jobs that humans might be able to do, that sort of acknowledges that there's like an embodiment, that there's some kind of embedding within a world that a system must interact with, and that there's a high degree of variation in that world that it must be able to deal with and accommodate to be able to function in its day-to-day. So that is a very strong notion of generality, I think, which you're connecting to, which I'm glad you brought that up. Does anyone else want to chime in? Maybe one or two more?
It
I
may
mean, I
not.
guess I could. Oh.
No.
Nadia,
Go
please.
ahead.
Yeah.
Just something to add. It's like, when I was trying to think of like what would convince me of general AI, like, I could really only think within the scope of like human intelligence, because I think this is like a common thing that, you know, people have, is like, humans are the most intelligent species, right? Therefore, what's artificial general intelligence must look and like function like us, but that may not be the case, I guess.
This is an awesome point as well, and I really feel that perspective. I always, maybe I've taken the Suttonian or the Rich Sutton perspective on learning machines through my years working with Rich, but that a machine will see its world through whatever signals are provided to it. If we had an intelligent system that viewed the world through all of the bits flowing over all the wires in the internet, I mean, that is should we believe that intelligence could not form in such a setting? Should we believe that the intelligence that forms there, even if it was doing amazing manipulations and living within this world of data, that just because it wasn't human-like, it wasn't really an artificial general intelligence? I wouldn't rule that out personally, but many people might, because it doesn't, walk around, go like pick up after its dog, or look for the morning paper if those still exist, or drive a vehicle or something on roads. I don't know. I don't go out of my house very much these days, so I'm sure there's still cars out there though. But I mean, like, we have these, like, a system to be embedded within a world and embodied in some way. The natural choice is maybe the choice that we just last heard, which is that it should be embodied in the way that a human might be embodied, or that a robot dog might be embodied. But embodiment could also take the form of being situated within all of those other diverse signals in the world, like, the bits flowing over network channels on the internet or something like that, or the connections between satellites up in the sky. So that's a really nice point as well. I'll open the floor for one more, and then I'd like to get into a discussion about the hallmarks of intelligence, because this is like really nicely opening up that space of conversation. Does anyone else want to, even if you want to just quickly just type something in the chat, if you don't really want to come on microphone, that's totally fine as well. But if anyone else wants to chip in.
What I wanted to say is there are quite a few big problems that it seems like humans cannot solve. And if an AI was able to solve one of those, like, climate change, nuclear war, whatever, that for me would sort of define it as general AI. If it was capable of solving a big problem we are clearly not able to solve.
Okay, so I'll use a concrete example of this. Maybe some folks here are familiar with AlphaFold. Again, I'll put I'm also a research scientist at DeepMind. I'm just going to briefly put on my DeepMind hat and say, like, yeah, DeepMind released a very large neural network model which is able to predict how proteins fold, literally peering into building blocks of our molecular machinery and understanding how like the A's, T's, G's, C's, and U's that build up our body get turned into three-dimensional structures, molecular machines that allow us to, like, keep fluid in our body and move structures around and actually move ourselves. The building blocks of life. Now, Kim, I'm going to say that, like, that's using advanced machine intelligence technology to solve a landmark problem.
Narrow, eh? It's still narrow.
But that doesn't seem like it's general to me. It seems very, maybe not narrow, but at least incredibly specific, despite having a diversity. I'm not sure I would call that solving AGI. I'd say that that's it's a landmark breakthrough, and it's something that will transform how we as a species move forward in the world. But like that to me is different than, say, maybe the agent that Nadia was pointing out, which is like an agent that interacts with this world in a diverse way, but is still maybe not, or Thomas, I think it was, that said that was like an agent that could do a job like a human. Those seem very broad by comparison, or at least very very adaptable to different situations. And so maybe I'm jumping the gun here. I'm getting into that. I'm getting into discussion about the hallmarks of intelligence before, but yeah, so I'm not sure. Like something like AlphaFold, I'm not convinced that I would consider that to be a general form of intelligence.
Yeah.
Even though it does something really like fairly landmark, like, figuring out molecular machines. Anyway, just a counterpoint. Okay, one more. What does AGI look like, if that's okay? And then we'll move into the next phase. Or we can do it now. 3, 2, 1. Going once, going twice. Okay, cool. So the next piece then is, like, we've just talked about, and I'm glad we covered a broad range of it. We've just talked about a number of different ways we might imagine strong general intelligence presenting to us. This is like our own, like, a much misappropriated Turing test idea, but really the idea that, like, to have a yes/no decision for us about whether or not something fulfills our aspirations for artificial general intelligence. The next two questions that we need to think about then would be, well, I mean, can we do a better job of that? Can we actually talk about the hallmarks of intelligence, or some of the specific elements of intelligence that we are talking about, and then start to think about those elements in terms of whether or not these are yes/no things that we should think about. It either has or does not have a property, or whether any of the properties that we may seek in our intelligence systems are in fact continuums. So this is the next step I think that we need to go into. And so let me just call out, acknowledging that video calls make all sorts of things harder than they normally would be if we were face to face. Let me just call out a few of the things that have already been said that I think are really, really important. The ability to, like, we've already spoken about intelligence as having goals. Now, we didn't explicitly say it as goals, but we brought up the idea that intelligent systems in many cases would have something that they are pursuing. There would be a pursuit or a end goal in mind, or an objective function that was being sought. So we talked about goals. We talked about systems that are in fact perceiving something about the world around them, so that they're actually perceiving something about an environment. It might be a fully non-physics based environment, like tap, tap. I have a whiteboard over here. You can hear it go thump, thump, thump probably. That's one kind of perceptual stream, is the perceptual stream from normal sensors and sensations from a physical world. We also talked about perceptions from a synthetic world. But either way, we talked about perception. Like, this is a thing that we talked about, that there's intelligent systems have goals. They might perceive things. They might take actions. And so whether or not it's a system in a general sense being able to carry out jobs like a human might do, whether or not it's a system that's making decisions about policy or strategy at large temporal timescales, that we might imagine that a system is able to act upon a world, or that there are choices or decisions, a decision-making process involved. We also talked about adaptability, the ability for a system to change between different contexts, to maybe grow and change over time with respect to new information that's being presented. So these are some of the general hallmarks we talked about. And again, I'll boil it back down to things like how a system represents the world, what kinds of knowledge or information or forecasts a system builds about those perceptions that it receives, what kind of actions it takes, and what kind of goals, decisions, and data it uses. But are there any other hallmarks? This is, again, opening up to the floor. So please feel free to either chime in via audio or drop something in the chat. But if there is another hallmark that you think is really important to intelligence, or something that you would, like, in any degrees think you would require to see to label something as, yeah, that's like, yeah, wow, we really solved that intelligence thing. We understand it. We built something that embodies intelligence. Please chime in now. What else is there? What else is required as maybe a requirement or a high desirable for intelligence as a phenomenon?
If I'm thinking to myself about, like, what is the highest order sort of intelligence or rational agency I would see in a system or an individual, like, it would be many things we discussed, but it would be like sentience, rationality, free will, and maybe being like a moral agent capable of changing or guiding action based on moral principles. So I don't know if that applies so much for machines, but that's what I would say for sort of rational agency.
Okay. Ooh, rational. Ooh, rationality. So that's a really hot. I'm just gonna camp on that one for a second, because I think it's really interesting. The idea that an intelligence might make what we would consider to be rational choices with respect to its learned valuations, its learned belief structures, and its underlying principles. Whether or not rationality is a requirement for intelligence is something I think a lot of people debate. So I'm glad that that's flagged along with the other aspects of things like beliefs or values or morals. I think those are it's an interesting question as to whether those are requirements, those are natural outcomes of a process of intelligence, whether those are artifacts that may occur during a process of intelligence becoming intelligent. That's really cool. I'm just looking again at our list in the chat of all the different disciplines, and so for music, Darian, I noticed that you said that you're studying computing science and music technology. One thing that I think about when I think about music, but especially when I think about patterns in general, is the ability to represent concepts and patterns in time. This is something that often we forget about, but the ability to maintain and generate patterns over large and small timescales. This seems like something that is really fundamental to intelligence, at least something I've been thinking about very hard for the last couple of years. But especially when we think about, say, imagine we have an AGI jazz performer like that. This is one of the case examples that maybe would convince me that we've solved AGIs. You have like a jazz musician that's, you know, jamming along in a free-form jazz club somewhere and playing along, or improvising like live music alongside poetry, as I know Kim and I both appreciate. So I think that for me might be one of those tells for, yes, this is something that has strength in the intelligence that it's demonstrating, but it's partly because of that ability to both perceive and generate patterns that operate on both very short and very long timescales and blending them together elegantly. So I think that's one thing. And I also see down that Alyssa is working in pediatrics, and I think about what we expect to see from some of the other life forms in our life, and what kind of exploration or curiosity or novelty and drives like that we expect to see. So there's a question: do we expect intelligence to be able to perceive patterns? Do we expect intelligence to be able to seek novelty and be curious about the information that surrounds it? Any other things from people? Any other hallmarks of intelligence that we might expect? There's a couple more that I'm surprised no one said yet, but I'm gonna wait for a second and see.
I mean, what Thomas said about rationality made me think, like, what about like the counterpoint of like emotions, right? Like emotional intelligence. Because to me, like, that's a whole other form of intelligence than what we've been talking about. It's still recognizing patterns and stuff, but it's sort of that level of like empathy and recognizing yourself in another that I don't know how that applies to AI, but I'd be really interested in seeing something like that demonstrated in AI.
I think that's incredibly important. And in fact, like, again, as someone whose actual day-to-day research is in human-machine interaction, the modeling of others is incredibly important. And there's open questions as to whether we would expect an intelligence to, by default, believe that there are other things in the world that are like it, and that it should be able to reason about or model, or whether those are those long time scale patterns that I was maybe referencing with respect to jazz music, but that other entities are in fact best represented as other patterns in the world that unfold over time. But either way, that I think a lot of people believe that for that the multi-agent approach to AGI is very, very important. There's huge research communities that are focusing on artificial general intelligence systems that are in fact that involve populations of agents, human and machine. And part of this is theory of mind. I think you just really nicely brought up the ideas like theory of mind, where you might expect a system to believe that other systems are thinking intelligent entities, and that they have like perhaps operate in similar ways to the agent in question. So that's a really important point. And modeling other agents is actually something that might be well considered to be a hallmark of most, if not all, of the biological intelligence systems that we see around us right now. So that's a really good one to call out. Anyone else want to chime in? Another one? We're covering quite a bit of territory. There's one that I'm surprised that nobody brought up yet, and maybe because it's very, very obvious, and we don't think that it hasn't already been covered by the other things we've talked about. But maybe one or two more.
I was thinking of creativity and curiosity, for example. I don't know how that would be in reflection with like how humans are able to discover things in an unexpected way, and how like that would have an association with AGI.
There's a whole range of things we might expect with respect to knowing one's unknowns, to seeking out unknowns, to balancing exploration drives and novelty drives. And we mentioned curiosity again before. There's something even deeper, which is sort of going down towards the realm of fundamental epistemology, which is the act of knowing and then trying to carve out, to understand the envelope of one's own knowing and then trying to expand it, is something I think that we do expect many forms of intelligence to pursue. I think this sort of links into some of the comments on chat, like Alyssa's comment that like reading between the lines or understand context in different situations is absolutely important. And part of that also gets down to the knowing what you know, and then how other things fit within that envelope of knowledge or envelope of captured patterns. Okay, in the interest of time, I'm gonna say the one thing that I was surprised. I usually, whenever I ask this, people are like, oh yeah, the first thing they say is, well, an intelligent system must have memory. And this is something that like almost everybody always says, and it's the one that I'm least attached to, because memory is a very squishy thing in terms of a definition. Does it mean keeping around a complete record of everything that's happened? Does it mean that Kim's robot dog is required to have a supercomputer in the sky that stores up every single frame that it's seen in its cameras? Does it mean that information is compressed down into approximations and estimations and expectations, and that's used to make future decisions? This turns into, like, from the reinforcement learning literature, things like value functions or large relationships between situation and the expected value of taking different actions. So memory is a really hard one, and in the deep learning literature now, people have used for quite a few years now the new like idea of replay buffers, where you just keep around a bunch of samples of your past and you keep stuffing them back in to learn from them. Maybe we do this when we sleep and dream, but usually people jump right to memory right away. So I'm actually quite surprised and interested that no one brought it up yet. Again, acknowledging that I think it's one of the squishier ones, and that the other things we've talked about are much more concrete. Okay, awesome. So let's move into the next sort of the next phase of discussion, or how I usually like to break it down. We've talked about the hallmarks. So first of all, we tried to identify for ourselves what might be a compelling demonstration of artificial general intelligence, and also in the process we talked about examples of narrow or specific intelligence, including but not limited to the things in Kim's background. Ooh, new chat. Hold on, I will stop talking and start reading. The ability to build or foster or engage with relationships, being part of intelligence. I think like relationships. I think just to be saying, I think you're thinking of relationships in terms of relationships between agents or relationships between concepts in the world, because those are both awesome points.
I don't want to say like agent to agent. Like, I guess I could also describe what I mean by relationships in like my relation to this cup I have, or my relations to the land that I'm on. Like, I don't think it has to be with like another agent that we would define as agent to be. Yeah. Okay,
awesome. I think that is the more encompassing and powerful definition of relationship, which I wanted to ask, because this is, you could argue this is central to everything from those awesome language models and chatbots that we were bringing up earlier, right through to robots that are trying to like work through a construction site or a disaster recovery site, is that understanding the patterns in an environment, in an embodied interaction with a world, and then being able to start to think about the relationships. Maybe I'm going to go a little off script. I mean, I don't really have a script, but I'm going to go a little off script and say that I still remember one of my, since Kim's encouraging you to think about the Satonian point of view, or the Rich's point of view on intelligence. I remember one of my earlier conversations with Rich when we first started working together was about the relationship between, say, me and a chair. And now this sounds like a simple example, but I think it's really great with respect to your last point, is that when I was talking to Rich about a chair, it's like, how might you think about a chair? And usually if you were like maybe an interior designer, I don't know, I'm not an interior designer or industrial designer, you might think about the extents and the bounds of it. You might think about the materials that it's made of. You might, if you were like something that I do, which is like build things in computer graphics worlds, like you might think about it as a bounding box, or a width and a height and a depth and a distance to. So we might think about our relationship to, say, a chair, or like this wall screen behind me. I might think about that in terms of like, physical distance. There's another way to think about that a machine might take, and in fact, many of the machines that we create here at the University of Alberta do think this way, if you want to call it thinking, is that you might also think about a chair as, well, what would be the outcome if I tried to sit down right now? This is a question it's a question phrased in predictive terms. It is a understanding of the world that is built upon predictions, not upon measurements. Now, they are measurements, don't get me wrong. A prediction is in a way a measurement. If I did as Kim suggested earlier and had you all running around outside in your hallways trying to figure out how many steps you need to take until you hit the nearest wall, it would be clear that that those relationships are in fact very similar. But again, thinking about a chair as a width, depth, or height, or thinking about a chair as what's the likelihood if I sit down right now I'd succeed. Those are two different ways to capture relationships between between things in a world. And I think that that works as well for other agents that might be considered thinking agents, or other agents that might not be thinking agents, or other just artifacts of the world, if there's a distinction between them. So that's a really good point. I think that is at the core of what we do hope intelligence does. Oh wow, we got lots of stuff now coming in on the chat here. This is great. So we got, I think if AI can experience and resolve, and this is one comment from Green, I was thinking if AI can experience and resolve an existential crisis, that would be a hallmark of intelligence because it is such a human experience. And so I think Nuri, if I'm catching that right, it's an existential crisis for the thinking machine. Is that right? Like it's not solving a human existential crisis, but it's that an agent is faced with a crisis of its own existence and then has to try to work to solve that. And that is a very, again, that's like reflected in what we do as human organisms and other biological organisms. If I'm understanding that right, I think that is a very interesting way to start thinking about about whether or not something embodies the hallmarks of intelligence. I haven't seen someone actually bring that one up actually in, as long as I can remember. That is, and what do we have? Huge milestone for general intelligence when general intelligence is able to advance and create culture. Now this goes down from just like phenotypic transmission, like how does the system even present itself to the world, but how does the system both incorporate ideas and then transmit and propagate ideas? This is, I think, really interesting for us as humans. We cultivate a meme pool, and here I mean meme in this, like memetics, in the sense of ideological transmission, mutation with fidelity and fecundity, and not just pictures of grumpy cat circulating on the internet, though those are one example. I really do mean memetics as the field of study, much like genetics. And so yeah, the ability to cultivate a space of mimetic transmission and in fact shape that space so as to propagate certain ideas and retain certain ideas that have proved beneficial. I think that, yeah, you're right. That's a very powerful act that we see in our current intelligences, at least human intelligence, and probably cetaceans as well. I think whales may actually be doing a pretty good job of this, whales and dolphins. But anyway, great books on whales and dolphins and their intelligence. If anyone's interested, there's a wide literature on that that's definitely worth reading. And also then I think Alyssa's saying here, which is something about the ability to understand different cultures and beliefs. So this is maybe going even beyond some of the theory of mind arguments and say that like you can actually start to notice and register your own intellectual setting within that of many other systems within the world, especially what might be considered other meme pools and other gene pools. So that's really cool. Okay. Wow. Okay, we covered a lot of ground there. So this is good. We went into the hallmarks of intelligence. We did that with me sort of putting my cards on the table and saying that I really think that a nice way, especially to talk about the applications of AI, to think about the hallmarks is to think about what data a system perceives, what kind of decisions it makes, and what kind of goals it's pursuing. And then within that sort of continuum, that movement from data through decisions to goals, to think about how a system perceives the world, what signals it operates on, how it represents the world that it's situated within, be it the internet or like a robot running around in a construction site. The things that it builds up, the things it maintains, be it memories or predictions or forecasts or what we might consider to be knowledge, what kind of information it stores and how it stores it, and then also what kind of actions it makes, what kind of boots on the ground decisions the system is able to make or reflexively make. So I think those are the hallmarks that I like to talk about. And I like to then, the thing I usually do from there, and I'll do it only briefly so we have time for a little more discussion on a different topic, is that from there I usually like to say that there's a few traps that I see people fall into regularly. And maybe I'll just say that now. I'll get like on my little soapbox here and say that there's a few traps that people usually fall into when they're thinking about artificial general intelligence. One of those traps is to think about it as a yes-no distinction. So often, I work very closely with a lot of clinicians, and we discuss very frankly the deployment of advanced machine learning technologies in a clinical arena. And so to do that, we have to be very precise about what we're talking about. Often I think that there's a perception by the general public, by non-specialists, in fact, even specialists in AI that well, a system is either intelligent or it's not. So right away, you would lump everything that like Kim's robot dog right through to like a Apple Assistant or an Amazon Alexa or whatever. You'd lump all of those things into either intelligent or not intelligent. And that's it. And you'd make decisions based on that sort of bulk aggregation of of what we might consider to be intelligence capabilities. Usually everyone goes one step further, and this is still, I think, a trap, but it's one step forward, which is to say that, oh, well, there's things that clearly aren't intelligent. Then there's like appliances, and then there's like artificial general intelligence. And so the minute you've had a robot vacuum cleaner or a robot dog for more than, well, I don't know, maybe a couple of years, you might have migrated like a Nest thermostat or one of those machine learning thermostats. You might have migrated that from, well, that's strong AGI and an existential threat to our species, to, well, that's an appliance. And I really like that it vacuums my floor, keeps my temperatures really, really level in the house. So the next step is usually going from yes, no intelligence to, well, not intelligent, whatever, it's an appliance, and then okay, this is a strong AGI, and then it's really just familiarity that sort of dictates the progression on the top end of that continuum. I really think the most healthy way to think about it, in fact, goes back to some of the discussion about narrow AI from earlier this session, which is to think instead that there are many aspects of intelligence, and any given system will demonstrate or work upon one of those aspects of intelligence to a greater or lesser degree. So this isn't even like saying appliances right through to strong AGI. It's saying that, wow, an Excel spreadsheet might do a really good job at crunching mathematical operations, better than I might if I was given my druthers in a little calculator, but it probably isn't going to be able to make toast. An automatic toaster with a machine learning module to not burn my toast. We actually got a toaster oven that also is an air fryer. It does an amazing job of like actually keeping the toast just perfectly brown. And it probably uses some kind of data model, maybe a really simple one. And it probably does a better job than me just like pushing the toast up and down inside a regular old fashioned toaster. So the different axes of capability, I think, are really important to study. And when we talk about an intelligent system, doing the whole, oh, it's either intelligent or it's not, this is AGI or it's not AGI, I think is actually a large trap, and it doesn't help us speak clearly or make fruitful conversations that help us really understand the consequences of technologies, our deployment of those technologies, and the development of future technologies. So thinking about any given intelligent system that we might want to consider with respect to the different axes of its capabilities, especially with respect to, as I said before, the data it takes in, the decisions it makes, the actions it might take in the world, the goals it's pursuing, helps us think a lot more precisely and to communicate a lot more clearly about any given intelligent system technology. I'll say just one example from the world of prosthetic limbs. In our lab on campus, we look at connecting artificial robotic body parts to people who've lost limbs due to injury or illness. Those limbs will have to take into account information sampled from the body of the human, say the tissue of their residual limb. It'll have to map those signals to some kind of patterns of control for, say, the movement of the fingers or the wrist or the elbow of a robotic limb, so it can act upon its own joints, and through its own joints act upon the world. It can take information from the human body, and maybe we might consider even giving it sensors like a temperature sensor or a little camera in its palm. But either way, this is specifying by what means it is able to perceive the environment, what kinds of actions it might take, and what we can even then start to say, what goals should the system have? Should it be, its goal should be to flawlessly produce the kinds of motor controls that the human using it wishes? Well, yeah, then we can be really clear about those goals and talk about whether or not it's achieving those goals. So this is not though saying, is this limb intelligent or not? It is starting to talk about the specific aspects or hallmarks of intelligence so we can talk more clearly. Cool. Okay, so that's the end of like the sort of phase one of our discussion. I think where I'd like to go next is to move into a discussion, a more broad discussion of what machines might learn, how machines might learn those things, and then when machines might learn. Is that okay with everyone? If that's our next, I actually have very limited signal to figure out whether or not you're okay with that, but I have like 3 people on camera and some chat windows, so I see no one like looking shocked and horrified at that plan, so I think I'll keep going with it if that's okay. Okay, cool. So we talked about machines. We talked about how those machines might present hallmarks of intelligence, how we might think about that. I gave you sort of one breakdown of how we might wish to consider hallmarks in sort of as a rule of thumb. But we haven't talked concretely about what machines might learn. And so I know Osmar's lectures will give you a very broad cross-section of examples of what machines might learn. But let's maybe talk very broadly. I'm going to open up again for questions since I've been talking for a little while here. I'm going to open up to all of you and say, like, like rapid fire round if you want. You could even just like write 1 or 2 words in the chat window. You could just say it on audio, but like what are things that a machine might learn? And a machine that aspires towards intelligence, what things might that machine learn? If you see me duck down, it's because I have to actually like scroll with my trackpad to figure out what people are saying in the chat window. Okay, cool. So I'll just start. People are thinking about it, so I appreciate that. I don't want to bias you by reading out the comments already, but I'll do a little. We had Darian say humor. Thomas said how to classify and identify and respond to emotions and responses. So I'll leave some room for a couple more. Nuances of language, the way people actually speak. Okay, awesome. Couple more maybe. I'll give you just a little bit of time to think and think and type. Okay, all right. I'll start to close it off though. This one off then. Thomas, I'm gonna zoom in on your response. These are all great responses. Thomas, I'm gonna zoom in on yours because I think that there's some general principles we can pull out of it, especially the way that you've strung together. So I'll read out Thomas's reply to everyone here, which is that how to classify and identify and respond to human emotions and responses. I'm just gonna actually crop off the bottom part of this and zoom in on classify, identify, and respond, because I think that those are examples or ways of saying a much more general thing. A machine might learn, as you said, classification decisions. And this might be, let's talk very, very generally about it, but also very precisely about this, is that it might be a mapping. A machine might learn a mapping from a pattern of stimulus to a label or a value. Okay, this is a very important thing that a machine might learn. Many of the technologies we see being deployed are in fact doing something of this kind. If you look at how ads are served on the internet and things like that, a lot of this is looking at either patterns of activity and then trying to decide, like, I'm sure Facebook, I don't know what Facebook actually does, but let's imagine that Facebook is looking at all of your contacts. It's a pattern of stimulus and then trying to figure out what kind of user group you might be within to serve ads. So you might imagine, I assume that's what they're doing. Again, I don't actually have any idea. You might when we're looking at, say, a lot of the image identification algorithms that are being used on the internet right now, it'd be you show a pattern of pixels and it says, yep, that's a horse, or that's a cat, or that's a still frame image from the Zoom call of Kim's course in the winter of 2021. Like, whatever it is a mapping of a pattern of stimulus to some kind of label or classification. There's also the idea that you might not map something to you might not map just to a label or a classification, but you might map to a value. And so for like a trial and error learning machine, like a reinforcement learning agent, like a puppy or a robot puppy or me, you might start to map a pattern of stimulus to a value. Like, how good is it to be in my basement office right now speaking to all of you? Somewhere in my brain, there's a value function that is capturing this mapping of stimulus to expected long-term reward for doing this. In the same token, you might imagine that you're like an organism running through the savannah, and you see a pattern of stimulus that might be like a predator, like a tiger. You see something ahead of you, it's got eyes in the front of its head, and it's got, I don't know, pointy things in its face. And like right away, you would start to perhaps think about the pattern of stimulus and your intended actions and start to build a value of the goodness or badness of those actions. Like, keep running straight ahead, turn around and run the other direction, hide in a bush. Let's say those are your 3 actions. You might start to map that pattern of stimulus and the possible candidate actions to the value of those different alternatives given your stimulus. So This gets as well towards the identification. So like that's like the classification either in numerical or valuation style terms. It's mapping of a stimulus to a value or mapping of a stimulus to a label is really important. That's something a machine might definitely learn. Identification might not necessarily even rely on the classification or the mapping to a value. Identification might be something that happens just based on the structure, the patterns of stimulus presented to a learning system. So this might be the learning to understand the underlying structure of the data that's presented to a system. So for like a compression algorithm, like the ones that you're using to, well, that we're using to stream video right now, or the images that you're viewing on your various electronic devices, there's almost a unsupervised process in some sense that's looking to find patterns in that data so as to compress that data in a way that can be shipped over the internet. This is a learning about the structure of the data. So we're learning valuations or learning classifications or labels, learning the underlying structure of the data. And then Thomas, I'm gonna pick on that last piece of yours, which is respond. A system might learn a way of directly mapping stimulus to actions. So this is the perceptions or the things coming into a system along with its state might be mapped to a way of choosing between different alternatives or actions directly, not as mediated by, say, things like the labels of the world around it or the underlying structure. There might be what we often call a policy, a mapping of situation to actions, or a mapping of states, as we call it, to actions. So this is another thing that a system might learn. And a lot of the other like, for instance, the other comments like humor and nuances of language, you might actually start to think about how those are then registered within the idea that a system might wish to map stimulus to labels or to values, might wish to find the underlying structure, might wish to learn the underlying structure of the world around it, or might wish to learn how to act upon the stimulus that's being presented with. Okay, so that's like a nice high level summary of the what. I'll boil it down to learning learning values or classifications of the world, learning the underlying structure of information, or learning ways of behaving. This like values and policies and some kind of representations are a nice way to break it down. Okay, cool. Let's jump into, again, acknowledging time, the how a machine might learn. I like this bit. This is really fun because as a reinforcement learning researcher, this is maybe the bit that I have to think about quite a bit. But imagine that you have a learning machine. It doesn't have to be one of those like strong artificial general intelligences we talked about earlier. Imagine that we have a learning machine of some kind, and it's placed within a world. It could be the world of like being presented with pictures from the internet. It might be a robot running around in the mud. But in general, thinking in a very general sense now, how might that system go about learning about the world that it's in? How might it start learning the what's that we just identified? Valuations, the structure of the world around it, the right ways of behaving. How might a system learn? And again, I'll open up the chat and then the video call for people to chime in with their ideas. And while you're thinking, Kim, how does your robot dog learn? How's this new robot dog learn? Do you pat it on the head? Do you have to give it verbal feedback? Do you give it literally a bone?
Yeah, there are many different things. He has a lot of different sensors. He also senses the edges of things and the distance down, but it's not quite sufficient to protect him from falling. So, but it is cool that he can sort of dance around on a small square and only occasionally slip off. And he's constantly mapping his surroundings from the ceiling. He has this camera right in front of his tail, pointed straight up. And everywhere he goes, he maps, and he can recognize if he's been there before and think back to what happened the last time he was there based on the way the ceiling looks. Yeah.
Well, okay, that's clever engineering. I appreciate the upward facing camera. That's a nice quick hack, and it's a very elegant one as well. Yeah. Very cool. So this, I'll go into, there's some responses from Nadia and Thomas in the chat, but I'm just gonna say, like, so Kim, when your robot puppy falls off like a table, is there any feedback? Like, is he less likely to do it again the next time?
No, I think it's entirely a human experience and not a robot one. I mean, the dog costs more than 4,000 Canadian, so I'm not going to let him fall, right? But when he falls, I feel terrible, right? He's probably not worried because he knows somehow that when he falls, he always gets caught. You know, he doesn't land hard ever. So he's not learning, but I'm learning because it was so difficult to get him here. I don't want to ever have to go through that again. So I don't want him to get damaged or dented or anything.
Okay, cool. So now, Kim, you are now my learning machine example that I'll use when I
Yeah.
start to go through these answers. But I'll go through some of the replies now in the chat. Thanks, Kim. That was actually a really helpful example, and we'll unpack some of that in a second. So Nadia, you were saying, quick aside, what we discussed about classification lead to a sort of machine intuition? And I can tell you my general feeling about that is that, yeah, it registers really nicely with intuition. If we think about especially machines that play games, either chess playing or Go playing or shogi playing or whatever kind of game, because I know games just came up as well in the chat, as well as how a machine might learn. But those really good game playing systems will often build up value, like essentially a state to valuation mapping and a state to action mapping. It's like, wow, we're in this particular situation in a chess or a checkers game, and then right away, often, not always, but right away, but without doing a bunch of mental rollouts, these systems might be able to quickly query for a value of making a choice of one choice or another choice, or might query for the best recommended action. And it might just pop into the system's mind simply by just passing in the situation. To me, this feels a lot like intuition, and it's intuition that doesn't just say what's the next best move. It is a immediate realization of the many possible branching futures that might roll out, but without any of that sort of labor-intensive like search over the space of the future. Like search is a really interesting part of artificial general intelligence, the way the system might begin to search. But I think, for me at least, a lot of the really impressive game playing systems, and also a lot of the very fast, like robotic sensory motor learning situations, I think those are, to me at least, very well mapped to some notion of intuition. That's the word that I often think about. So I think that's a really astute observation. Is my video choppy for everyone, by the way? Just a thumbs up or thumbs down. I'm monitoring my own. It's okay? Okay. I saw myself. I have a little monitor window of myself. I'm like, oh, I look like I'm doing the robot. Okay, cool. So let's go down into how a machine might learn. And so Thomas pointed out that a machine might learn by looking at results of real examples, looking at the results of lots of computer-generated examples, positive and negative incentives. So there's a bunch of stuff there that I think we can dig into. Alex noted that there's that a machine might get some kind of representation of the world, perform some kind of action given that representation, and then maybe get a good bad signal like, oh no, the dog fell off the table, and then get a new world representation, start the process over again. This is like, Alex, this is like 100% the reinforcement learning view of looping the world. You have a perception of state, you take some kind of action, and then you see a new situation and reward, and you repeat until intelligence. So like that is very much nicely capturing as well some of the cores of one mechanism of learning. The idea that a machine might learn through games is, again, also there's goals involved. There's making choices and viewing the outcome of those choices. I mean, a lot of us here at the University of Alberta that study reinforced learning care a lot about the playful approach to artificial general intelligence, where systems really do try to build up an understanding of the world through ongoing interactions with the world that might not even be in service of their primary goals or rewards. So I'm going to now sort of do what I did for the what and try to do it for the how. One way, and the usual three ways, I'll say the three ways that you might have read about, and Osmar may have already told you, but with the same or different names, are what we usually think of as learning by presentation of labeled examples, learning through trial and error, and then again, learning through observation of the structure of the world. And so let's just focus. We already talked a little bit about learning from the structure of the world. This is again seeing lots and lots and lots of real examples and maybe being able to cluster them in different ways. But let's look specifically at learning through labeled examples and learning through trial and error. You might see this if you're reading papers or looking through the coverage of this, that you might call it supervised learning, unsupervised learning, and reinforcement learning. As the three cases I just identified, that's the common names you will see. I've been encouraged especially to think about supervised learning as a process of learning through labeled examples. What do I mean by this? I mean that you might actually have a presentation of different examples, let's say pictures from the internet, like, oh, that was clearly that's a horse, or this is a picture of Iceland. I know in some of my slide decks, I have pictures of different landscapes. But you might see a bunch of pictures, and the system is asked to make a decision, a classification or evaluation of that particular image that presented to it. So let's just imagine I was like holding up a flashcard to Kim, and I'm like, okay, cool, Kim, what is this? There.
It's a bird.
It's a bird. Great. Okay, awesome. So then I'd be like, yep, good job. And that saying good job, essentially it's like I just presented Kim with a sample, and he provided me with a label, and I confirmed the correctness of his label. So what's important about that process that we just pursued is that there was a label that the system was being asked to generate. This could also be a numerical label, and then the true answer was given. Okay, so this is learning through a process of labeled examples. And for instance, I might just try this again, and I might say something like, I can say So Young on the camera there. What is this that I'm holding?
A dice.
Yeah, absolutely. So then I'd be like, yep, that is absolutely correct. And then I might go to Nadia, like, Nadia, what kind of plant is this?
A leafy one. I don't know.
Right. And so then I might be like, oh, okay, leafy, that's a good answer, but it's actually a ZZ plant. And that's anyway, so then you might be like, oh, cool. And next time you see a ZZ plant, you might be like, yep, that was a ZZ. It's definitely leafy, but it's also a ZZ plant. Thank you for hearing my learning examples. But so all three of you. So this is a process of learning through labeled examples. You might actually have some kind of process wherein the correct answer is known, and it's delivered to the system, either in like the sort of flashcard example I was just using right now, or in like, hey, this is like, I took this trajectory as a robot drone flying through a disaster recovery site, and someone says, no, the correct trajectory should have been this. You bumped into a wall and lost your propeller, little drone. You should have gone this way. And then the system updates its internal machinery based on that sample label pairing. The other way is very much the robot. This is what I think in Alex comes out in Alex's comment. So in the games example as well, I think the games example is very much suited to the learning through trial and error, especially the dominant solutions to machines that play games, and to the positive and negative incentives that Thomas mentioned in his comment as well. Is that if Kim's expensive and highly detailed robotic system falls off a table, it's less of a case of like when, and then Kim, of course, corrects his behavior and maybe the behavior of the machine so that it doesn't fall off the table next time. It's less of a case of, oh yeah, this is exactly how you should have behaved, and now you behave like this. It's oh wow, that was really, really bad, and then you change your decision making. So maybe Kim changes the decision making, or he changes some of the macro programming of the machine so that it doesn't do that again. Learning through trial and error is very much saying that maybe the right answer in terms of the actual behavior is not known, but the outcome is. This is the sweet spot of reinforcement learning, which is to say that you might be able to get signals of good, bad, or success and failure. I might know when a robotic limb in my lab that's attached to someone's body has given a very natural handshake or picked up a cup and not spilled it. But I may have no idea what the correct motor trajectory is for that robotic system to be able to affect that behavior. I may have no idea. But that's okay, because in a process of learning through trial and error, we can imagine a how. We can imagine a mechanism by which a learning machine might be able to begin to sculpt its behavior in response to just the signals of success or failure, the incentives of positive or negative reward that is given over the course of a task. For the little drone going through the disaster recovery site and bumping into walls, imagine saying, hey, bumping into walls is bad. And it might learn through trial and error not to bump into walls and to be able to fully scan the disaster site without resulting in a mechanical failure. Now, maybe that's, in this case, harder and more expensive than someone saying these are the correct kinds of trajectories. And there's, of course, a middle ground, but I do think that these are two very important hows for machines, is that one is learning through a process of being presented with the true example. This might be like, hey, you should really prescribe this particular prescription. And then it's like, oh, well, no, this is you really should have been prescribing this prescription, not this prescription. If it was like a pharmacy dispenser system. As opposed to, oh, wow, that prescription, that didn't go over so well. Well, I guess we better try something new next time. Like, there are clearly cases where you may wish to appeal to one or another mechanism of the hows of learning. Okay, I'm going to go into the whens of learning, and then I'll leave a little bit of time at the end, because I think we go to 3:20. Is that correct? Okay.
Yes.
So making sure that everyone gets as much non-video time call in their days as possible. I'm assuming you all have like eyeball fatigue like the rest of us. I'll try not to go over time here. But I do want to quickly touch on the whens of learning. And I'm just in the interest of time, I won't open this one up to discussion as I did for the previous ones, but I'll just say very briefly, and I apologize if any of you have been into a previous lecture with me and I've given all of these, well, you're hearing it again, but the whens of learning are also really important. We talked about learning things like valuations and policies and information representations, or the structure of the data. We talked that those things might be learned through trial and error, or through the presentation of labeled examples, or through some unsupervised process of clustering of the data based on some clustering metric. But when that happens is also really, really important. And so what do I mean by when? Well, there's one approach which would be to say that, well, a machine should only learn in very specific instances. Like, imagine you have a factory robot and you want to behave perfectly when you put it out on the factory floor to say weld the doors on cars and things like that. Imagine that machine was a machine that was trained through machine learning or machine intelligence. You might wish to store up a bunch of data and then have that machine learn all at once and then never learn again. This is actually a really common case. It's one of the most common cases, which is that we call it offline learning or batch learning. You store up a ton of data. You take a lot of examples about let's say, sample label pairs. You might, for an image classification system that you wanted to put into an app you're developing for your phone, you might want to store up a ton of those images with their labels. You might want to train the machine on all of those sample label pairs and then never train it ever again. When you actually put it into operation, when you actually put this thing into use, it's like taking a giant vat of data and you sort of pour all the data in, you put it on the fire, and you stir and you stir and you stir for like, I don't know, like 70 billion teraflops of compute. And eventually it boils down into this nice little reduction that you can sample as your soup stock. The soup analogy is very appropriate because usually it is a boiling down process of many sample label pairs, or maybe even many trial and error simulated learning interactions that are then stocked up and then trained all at once. But you might train a machine offline or in batches, and this is a really common case. The less common case, so that I think is that pretty much clear to everyone? Is there any questions on what it means to like do that sort of offline or batch learning process? You can even just type like clarify or you're talking nonsense, Pilarski. Those are all fine things to type into the chat window if you want to. Okay, if you do, just please pop it there. I'm going to go into the other kind, which is the kind of the when of learning that I am most passionate about, and the kind of when learning that I study, which is that a machine might learn all the time. And this sort of goes away, for those who are familiar with like training and testing splits in machine learning and data science, this almost goes away from that idea to say that a machine might learn during its ongoing operation. This is like real time, or what's called online operation. Although if you ever publish a paper on online learning, you might just get a lot of queries to come talk at education conferences. Turns out that's a thing. I stopped putting online learning in my titles of my papers. But really, this is the idea of real-time learning, that a machine might learn during its ongoing operation. This doesn't say you stock up a lot of data, you train a machine, then you throw it in the world to do its job. It's you throw the machine out into the world and it's learning while it's out there doing its job. For an artificial limb, let's say, let me contrast those two examples. It might be that in the clinic, a patient comes into the prosthetics clinic, let's say at the Glen Rose Hospital here. They work with a prosthetist and other members of the clinical staff there to be fit with a prosthetic limb. That prosthetist like helps them tune all of the knobs of the robotic limb so that it responds perfectly to their signals, and then they're sent home with it. And the control machinery, the way that the the artificial limb maps their signals to the way the hand or the arm or the wrist opens and closes and turns and rotates, is fixed. All of that learning was done inside the clinic if it used machine learning. The online approach would be to say that maybe you do all of that, but then as soon as that person goes home, the machine is still learning and changing the way that it's mapping, say, signals from the person's residual limb to the control of the robotic limb. So the learning process doesn't stop at deployment. It continues on while the machine is deployed in the world. I think a lot of what we see in biological organisms, you would argue, very much is a case of real-time learning. Systems are in fact learning and adapting things like their policies or their valuations, the what's of learning. Their representations, their valuations, or their policies are being adapted in real time and during their ongoing operation. And those adaptations occur in real time via a process of trial and error, and also via a process of learning through labeled examples. But those are the two when cases. So just to summarize, then we can open up for questions. We started out with a broad discussion of what AGI might look like if we were to declare, like, yeah, I just saw AGI on the street and it looked like this. We broke that down into some of the hallmarks of intelligence, and I was encouraging everyone, and you don't have to believe me or take this as a breakdown, to think about data, decisions, and goals, and the way that representations, knowledge or predictions, and actions or policies sort of feed that process of turning data into the achievement of goals. We talked about the way that we should think about intelligence not as a yes/no question or as a appliances, AGI, not that smart at all kind of continuum, but really as a diverse set of capabilities that each should be identified. And then with respect to those capabilities, the what's that might be learned to support them, the how those things might be learned, and the when those things might be learned are the last things that we broke down. And in terms of the what, again, we might learn valuations or labelings of the world. A system might learn how to represent the world, or how to structure the world so that it can do future operations. And a system might learn ways of behaving within a world, actions, policies, values, and representation. We talked about the how a system might learn, and again, learning through labeled examples, learning through trial and error, and learning based on the raw structure of the world. And this is what's usually called supervised learning, reinforcement learning, and unsupervised learning, respectively. And then the whens of when we might learn in batches or in an offline sense before a system is deployed, or learning machine or intelligence might learn during its ongoing or deployed operation. And so that was actually a lot of content. Thank you for hearing me. Let's maybe do, if there's any questions for 6 minutes on whatever, I'm happy to take questions for 6 minutes. Or if you thought there's something I really did a very poor job of walking us through today, please jump in and ask me to clarify, or ask any of your colleagues in the class to clarify as well if you thought something was really cool from one of the earlier comments. Or you just ask him how he did the robot dog. Okay, cool. We have a question.
No, I was just thinking during my head, like during this whole talk, which thank you for the talk. It was very interesting. I learned a lot, have a lot of notes down. The question of like general artificial intelligence. And I noticed you used some terms like embody and stuff. And I know like Latour uses a lot of terms like that, you know, and he talks about like technology as being like an extension of the self, right? Like when I write with a pen, it becomes a part of myself. And like, I guess in defining artificial intelligence, I guess it's like when it's like no longer an extension of yourself, when it's its own like separate entity. Because even some of the current AI stuff, which like identify stuff, like they still perform functions that humans can do. So they could still be like considered an extension of like human functioning. But like once AI goes further than that, and it's like no longer an extension, I guess. Just a thought I had to throw in the bucket.
This is awesome. We could do it in a whole hour and a half. This is the area of study that I actually study, which is intelligence amplification. How one system and another system come together to become more the sum of their parts. When do you call them two things versus one thing? When is, like, for prosthetic limbs, is the prosthetic limb a partner and a collaborator, or is it part of your body? These are like the questions we talk about every day, and they're like my favorite questions to talk about. What's interesting about your question as well is that you could then ask, when do we become an extension of the machine? Is the dual of the question is say that like there's a point when maybe a system stops being an extension of us, and that's like that might be a really clear way to start to say, yeah, that actually then became something independent enough to consider a artificial intelligence. And then the next question is, well, when do we become an extension of that? And that's not like the sense of the Matrix, like, hey, you're just like a battery that we plug into our simulation. I don't mean it like that, but I do mean that like if we think about us working together with machines, you can almost think about it like a Venn diagram, and there's an overlap of things that we do, and each piece does something different. But there's also size differentials in the Venn diagram. And so maybe right now what we're seeing is the human mind, the human intellect is a very large circle, and there's a small but maybe very pointy oval that intersects with it, which is what we consider machine intelligence. And the more narrow the AI, the more pointy that might be. And that it only overlaps with one very small thing that we do, but it does so to a degree where it can have capabilities that we certainly don't have. But as that sort of very narrow ellipse starts to widen, we might imagine that in fact it absorbs more of what the capabilities that we have in terms of being able to see what we see and act on the same space that we act upon. But it might also get a lot bigger, like that internet we talked about earlier, that the internet AI that just acts upon the data streams of the internet. Well, that might be gigantic, and the overlap with the human bubble might be very, very small. It might be able to like drive a car, and we can drive a car, but it certainly won't be out there like mowing the lawn or making toast or singing, let's say. And so then, yeah, there's a case where those bubbles change in their relationship to each other, and then by the same argument by which we are saying that we're extending ourselves with our technology, then we might be able just to reflect that argument and say technology is extending itself with us, and it's very hard to know when it's the right time to make that call. Thanks. That's a really cool question. Oh, we have one more. I'm gonna try before I knock over this whole screen before me in my excitement by looking down at the chat window here. What are the greatest problems for achieving general AI? Oh, cool. Progress has been slow. Progress has been super fast lately. Actually, I think we're doing a great job in moving towards things that we can really understand, and also that demonstrate many of those properties of intelligence that we talked about earlier. What are the greatest problems right now? I have a sort of pet speculation. I'm just going to say it's a speculation. I'm thinking very hard on this because I don't want to be like, oh, we should just solve this thing, and never tries to do it, and then I'm just sending you all on the wrong path. I think that the ability for systems to think about and search over patterns at vast timescales is still very limited. Now, maybe this is too specialized, or maybe you're hoping for something grander in this question. But if we think about everything from the language models that sort of interpret our speech on our iPhones, right through to our machines that are deployed in the world, to like robots crawling over construction sites or vacuums that are in our house, the time span over which they synthesize patterns and the length of experience that they have or that they forecast over, the patterns that they think about, are often on the scale of seconds or minutes. They're not on a scale of years. There's no systems that appreciate, with respect, there's some weather systems and large scale systems that are starting to look at like weather patterns over decades. But for the most part, systems that can begin to integrate and generate patterns that extend over vast spans of time is something that I feel is really, is currently underexplored and incredibly hard. And the research is incredibly hard, because much like doing a clinical follow-up on say an intervention trial that requires 2 decades or 3 decades to find out the final outcome, it's really, really hard to do these kind of trials. So that's why it's not that people are lazy or people that aren't thinking about it. It's that it's really hard to do this kind of research and truly understand. So my feeling is that as we move towards more general forms of AI, I mean, I've been around on the planet probably, well, looking at, I've been around longer than perhaps I would like to admit, but our systems haven't. Our machine systems, even those that are deployed, are not synthesizing learning over long periods of time, understanding those patterns. How many winters has our usual vacuum cleaner robot been around? And the answer is not that many. So I think vast spans are something that are very hard, especially when a robot or a machine of any kind might start thinking on microsecond or nanosecond scales. The number of samples it will see is astronomical, and I think that is a really hard thing to think about for the machine and for us as researchers trying to work towards stronger forms of general intelligence. Cool, we're at time. thank you, everyone. This was, again, I'm always surprised when Zoom calls are engaging because it seems really hard to do. But thank you all for being engaged,
Yeah,
despite the fact that
thank
we're all
you.
little bots.
I have one more question.
Do we have time? Is that okay, Kim? Can we?
Yep.
Can we?
Yep.
Okay, if everyone's eyes don't start, please. Sorry.
I'm just wondering how like biases are eliminated. Because I'm assuming that a lot of things that we might be redefining or restructuring and perceiving and understanding differently are having some sort of like human impact or input, I guess. So yeah, I'm just curious as to how the biases are eliminated and how, when there is like a lack of representation or a form of erasure just because of the lack of ability to, or yeah, the lack of like ways of accessing knowledge or informations, how that's mitigated.
I will first make a disclaimer that I am not a, there's entire teams of, there's thousands of people right now, like exactly right now, working on this exact question and thinking very, very hard on it. I am not an expert in a space of, say, debiasing large data models for large language models or something like that. This is something that's really important, and everyone is thinking very, very hard on it right now, because imagine that you trained, let's imagine you trained like a chatbot. I mean, you probably know these examples already. Imagine you trained a chatbot on only linguistic information sampled from, say, the 1900s to 1930, and you deployed it in the modern day. Would that make any of us happy? No. Would it make some people really unhappy? Yes, because there's a huge amount of bias in the data that's being used. And so this is why I mentioned, like, if you want to understand the complete answer to how people are doing this right now, it's worth looking into the work that's being done by folks all around the world on debiasing language models, because this is just one of many examples. It's not just language models; it's everything from how self-driving cars might drive to anything else. But the answer is that yes, anytime you are training, especially training based on labeled examples, but you're training a system by giving it a vast amount of data, the distributions of that data will ultimately, of course, start to influence like that sample label pairing. Like if I kept holding up that ZZ plant and I said it was actually a fern, like that is a biasing act that would be like, we should be able to correct it. There are ways that people believe that it's possible to even if you have a biased training example set, to be able to create better balance and structure in that according to some established principles. Again, I'm not an expert in this area, so I don't want to speak to it. My answer, for at least for the domain of trial and error learning, is that in fact trial and error learning presumes, to some degree, if you're doing this in real time and online, it presumes a system that adapts. And so systems that adapt already are going a small way towards this. But if the only interactions that a system has are with let's say a subset of the population, or if a system is only interacting in a factory, I'm just gonna use a factory robot setting. If it only is building, it's in Alberta, and it's only building really large fuel inefficient pickup trucks. And you want that system to be able to build like a small EV smart car for California. It's probably not going to do a good job. Even though it's a system that might learn and adapt in real time, it would have the potential to start to build good micro smart cars that are all electric. But it would be clearly biased towards building larger and larger pickup trucks. And so I think that this is an example where it doesn't, like, just learning through trial and error or learning through a adaptive process does not help alleviate the need to think really hard about this, because absolutely the setting with which a system is deployed will bias its policies. This is true for biological machines as well, as I think is very, very evident in the world today. So I don't think we can get around it in any straightforward way of saying, oh yeah, system will just adapt, it's fine. Or we'll just remove X number of samples that we think are part of the bias, because I don't think any of those are going to be satisfying answers. But again, I'm not an expert in debiasing systems, especially given my line of work is on individual to individual interaction, where a system starts from tabula rasa with absolutely no biases, and in fact is trying to get biases. A prosthetic limb is trying to bias 100% towards its user in many cases, and so I think it's almost the dual of that. Is like, how does it actually custom fit and optimize to an individual through a process of precision medicine? Sorry, long answer to your question. I hope that was helpful.
Thank you. Yeah. Thank you.
The dog has cloud storage of his memory. Okay, cool. So Kim has a supercomputer in his house. That's awesome. All right, everyone, I think we should all go so that everyone gets time away from video calls. But thank you for such an engaging session. Tiana, I'm sorry I didn't get to your question, but I think it probably is best that we end. And Kim, thank you again for having me here to chat with everyone. I really enjoy this.
Thank you. Okay, take care. Great session.